and I have this organization, right, and I relate them to. The organization can turn the lights on or turn the lights off. This actor can walk in the building or walk out of the building, right? With functional programming, I have the ability to turn the lights on, and maybe an organization can do it. Or maybe it's not an organization, maybe it's a garage. Maybe it's a Walmart, right? But the turn on or off the light is kind of abstracted away from whatever that object is. And the fact that if I turn it on, I just say, turn on the garage, or turn on the lights at Walmart. It's the action is the first-class citizen, and you pass in your object to manipulate. So that's functional programming, and it works very much like Legos. Have you ever played with Legos? Yeah? So with functional programming, instead of embedding your logic inside the object and essentially creating a new crazy set of inputs and outputs for every object you build, like methods and properties and things like that, you have this function that has inputs and outputs. And if you notice with a Lego, every Lego has studs, and then they have the ability to take studs at the bottom, right? No matter what size it is, they all fit that same principle. So when you take Legos, you can build the Death Star. You can build a life-size statue of Tom Brady, right? You can do anything with Legos, and nothing really stops you because you have the same input and the same output. That's the principles of functional programming. That help?
Oh, absolutely. Is it new?
It is very old. It is like 60 years old now. And it's reemerged because our platforms have changed a bit. Back in the 60s, and actually, the curious thing is Alonzo Church, who invented lambda calculus, really is responsible for functional programming, I think. But he actually wrote the first functional programming language, lambda calculus, before there was even a computer in the 30s, right? So it goes a long way back. Why it's reemerged as a popular paradigm is because we've outpaced Moore's Law. Are you familiar with Moore's Law?
I've heard it in my basic computer concepts.
So back in the day, we had 8088s, which was like 16-bit or 8-bit processors, and Moore's Law came around and said, you know what, every year or every 2 years, this is going to double. Our computing power is going to double. And while it doubles, we can run essentially all of this logic on one machine. But we have gotten to a point where we can't continue to double the processing power, so we add cores. Like, you may have heard the term of quad-core machine processor, or a 16-core. I think the new Apple Mac Pro has 27 cores, right? 27 cores and 64 gigs of RAM, right? For $5,000. You can actually have a computer that takes more computing power than what we use to launch rockets to the moon, right? It's pretty crazy. But that's how we've been able to expand past Moore's Law, is to continue to add cores. And then we've also added this thing called the internet, which has created distributing computing. And distributing computing means that instead of trying to have everything run on one server or one computer, you can actually split all your tasks amongst all kinds of other computers, let them process and communicate back for a solution. Well, object-oriented programming, those patterns aren't terribly great at doing that, right? Because they want that model of the world. So when you try to break up an object-oriented system and say, hey, go run it on 1,000 computers, solve the problem, and come back, can be very challenging. And that's why functional programming has come back, because it's actually built with that pattern of breaking up all your little functions or Legos, breaking up all the Legos out to the far reaches of the earth and say, hey, build an alligator. And then it comes back and you've got this Lego alligator creature thing. So that's a little bit about those paradigms. Again, I think object-oriented paradigm is very important to know, and there's a lot of great resources to learn that. I think Trident does a great job at teaching those paradigms. Functional is a bit of a leading edge. Functional is up and coming, and it's gaining a lot of traction, but it's definitely been up and coming the last 5 or 6 years. And the reason that we teach that is because we want you to be able to solve the problems that you'll face with all the tools. So we want you to know all the tools in your bag instead of just one tool. And it's just, you go to work at a software development team, and they're looking for input from you, and you're going to want to know, maybe not be super great at every one, but know why someone's choosing a different paradigm versus another one. So, cool. Let me see.